Welcome to a video entitled Understanding Concurrency. Now, the best way to understand concurrency is to understand what our databases are doing for us. They're collecting our data into these structured, centrally located repositories so that anybody who needs access to the data can get it. And so concurrency refers to the fact that multiple people will be working in that database simultaneously. And no doubt, some of these people are all going to be trying to simultaneously work with the same rows of data. And so we're going to have to figure out some way to keep the actions of one person from stepping on the actions of another. Now, this happens every morning on the freeway on the way to work, right? We have a concurrency issue on the freeway. Everybody's trying to use the freeway at one time. So what have we done to alleviate that problem, or to not just alleviate it, but just to deal with it? We've put lanes on the freeways. Some lanes have been designated as high occupancy vehicle lanes. Some lanes large trucks can't get into. And then sometimes we have traffic lights regulating how many people can get on the freeway at once. So we're trying to deal with letting everybody use the same thing at the same time, but still get their job done cleanly. Now, SQL Server utilizes a system of data locks to prevent users from modifying data in a way that affects other users. And there's two main theories about concurrency control. One is called pessimistic concurrency control. And with pessimistic concurrency control, once a user starts to perform an action on data, a lock is applied to that data because, number one, you don't want to change data while somebody else is changing it, and you don't want to allow people to look at data that's about to be changed because they're looking at data that's not real. So other users cannot perform actions on the data that's locked until the original user releases it. Now, SQL Server is based on pessimistic concurrency control by default. Now, optimistic concurrency control says that the data is not locked when users just read it, but whenever a user updates a data, then the system's going to check to see if another user has changed the data after the original user read it. If so, then what that means is, hey, wait a minute, two people are trying to change the same piece of data here, so an error is raised to one of the people, and they're basically told, yours failed, go back and do it again. And once they get back and do it again, then the data will have been changed by the other person and shouldn't be getting changed again very soon. So with pessimistic concurrency control, you have more locks and you may wait for data longer. But with optimistic concurrency control, you tend to get more rollbacks of data and more errors raised and so forth. Generally, pessimistic is used on large, busy databases where you got a lot of people trying to do a lot of the same things to the same data. Optimistic is usually when the database is a little smaller and you don't have so many concurrency issues. Now, SQL Server, along with pessimistic locking, uses two main modes of locking. There's other modes, but let's just talk about these. Shared locks, and this is where multiple people can read the same data, but then those locks can be what we call escalated into exclusive locks, meaning, hey, wait a minute, now I'm making a change to this data, so nobody else can touch it, nobody can do anything with it until my transaction is complete. So once my transaction is complete, that means it's either going to be successful and the data is going to be changed, then you can see it, or the transaction is going to not be successful, it's going to be rolled back, then you can see it and it'll be the original data before I ever got here. Now, SQL Server concurrency can be adjusted. So we're not stuck with what we have. So based on how busy or how much concurrency is going on in your database, you can adjust this somewhat using the transaction isolation levels. Now, read committed is the default transaction isolation level on SQL Server. Data that's being read acquires a shared lock, and any data that's being changed has an exclusive lock until the transaction is completed, either committed or rolled back. And I'm going to demonstrate this to you in the locking and transaction examples a little bit later on in the course. We'll get out there and code and work with it. Read uncommitted allows readers to read uncommitted data. Now, that means I've started a transaction, I've made some changes, but I haven't committed the data. But if we're in read uncommitted transaction isolation level, you can read that data that's not committed. Now, the data may change and it may be rolled back. And then if you go back and read it again, it looks different than the first time. This is called a dirty read. Okay. Generally, most people don't want that, but you can have it. It'll prevent a lot of locking. A repeatable read ensures that data read in a transaction can be reread later in the transaction. Once I get a transaction going, you can't come into my transaction and make changes to it. But you can add a new row to the transaction because the new row wasn't there when I started and it's not going to affect me. Serializable says, now this is the strongest level of concurrency. You can't do anything to the data once somebody starts. You can't insert rows. This will result in the most locking, but this will also result in every user looking and feeling like they're the only person using the database. But it will slow down. There'll be a lot more locking going on. So that's concurrency. Now, there's a lot going on here, and I would strongly encourage you, if this is a whole new ballgame to you, to go out there in the books online and read about concurrency and make sure it's all making sense to you before you go take the exam. There are other transaction isolation levels, and I didn't mention them here because we don't want to go that deep. This is not a course on architecting, but it is a course on programming T-SQL, and you do need to understand concurrency and locking and how your code can affect those.